Alright, this is question 8.2.1 from the June 2021 question paper, and you are asked to determine or determine, find f prime x if f of x equals x squared minus 3 plus 9 over x squared. And there are two main things you have to note here. The first is the notation. So if they give it to you like that, you have to keep it like that. You have to say, all right, you gave me f of x, which is x squared minus 3 plus 9 over x squared, right? This is the f of x that you gave me, and I will find f prime x. You shouldn't change it to dy dx or dx, just keep it the way it is. So the second thing is that you need to simplify before you start doing your derivative, right? You need to simplify, and by that I mean this x squared here, it's in the denominator, so we want it to be up in the numerator so that we'll be able to derive correctly. So to do that, we're going to say, remember your laws of exponents. This is going to be f of x. Remember to keep it as f of x while you're still simplifying, because if you write a prime here, if you do this but you're still simplifying and you have not derived, then that is going to be incorrect. So we have to ensure that it's still just f of x is equals to x squared, everything else remains the same, minus 3 plus, I'm just going to do this, the x becomes a numerator and the exponent becomes negative, right? That is a law of exponent. We know that if I have, usually we write it like 1 over a, and it is the same as a over negative, and that is a law of exponent you need to remember, because if you do not remember this, then of course your answer, you're probably not even gonna realize that that's what we need to do here, right? And then now that everything is ready, we're just gonna say, okay, f of prime x equals to, what do we do? The exponent multiplies with the 1 here, right? There's a 1 here, and so the exponent is going to multiply with the 1. I'm going to do this step by step because this is the first calculus video that I'm doing. So we're going to say 2 times 1 so that you see it carefully, right? The 2 multiplies the 1, and then we still have the x, and then from the exponent we subtract 1. So the derivative of this thing here, the negative 3, is going to be 0. And if you think about it, it makes sense because we have something like this, negative 3x 0. If you were to derive this thing, let's say you wanted to derive just this thing here, what happens is, because our process is like this, taking the exponent, bringing it down to multiply with the coefficient, you're going to have negative 3 times 0 x 0 minus 1, which doesn't even matter because this whole thing here, this is gonna be 0, and what you're gonna be left with is 0 times x negative 1, and that's just a 0, right? Remember that your coefficient or your constant has this part right here. It has this 1 because this x exponent negative or x exponent 0 is just 1, right? So every time when you see a constant, remember that its derivative is just a 0, and this is how that happens. It happens because of that factor right there. So we're just gonna have plus 0, and then now Here we're gonna have plus 9 times negative 2, close it up, and then x negative 2 minus 1, right? I'm doing the same step on each of these terms here so that you understand that the process is the same even on the constant. That's what I did here. The process is always the same. Take the exponent, multiply it on the coefficient, and subtract 1 from the exponent. And then we're going to simplify this. We'll have that is just 2x, and that's just 0. We're going to have minus 18x exponent negative 3, right? So that is your answer, but you're not going to be penalized if you leave it like this, but leave your answers in a nice way so that they see that you know what you're doing. We're going to say 18 over x3, right? That is how you do derivatives. That is how we find f prime x. Remember that we maintained the f prime x. We found f prime x. We didn't find dy dx or dx and all that stuff. And that is that.